Hi there, Mr. Sutton here, bringing you the IM3 Honors 1-1 Extra Practice Number 4 solutions on domain range and functions. On this problem, I'm trying to figure out f of -1, 0, and +1. So this is basically asking for the y values on the graph here when I plug in these three different x values. If I plug in -1 for x, taking a look at the -1 value, the graph itself is at a value of, well, let's see here. It's not exact, but it looks like it's pretty close to negative, let's see, this is 3, 4, 5, 6, 7, 8, like somewhere between 7 and 8. So let's call this -7, I guess. But I guess you could call it -8. Either way, somewhere in there. So we'll say approximately. And then for f of 0, so this is the x value right here at, or the y value at x equals 0 right here. And that's a little bit more conclusive. That definitely looks like -6. And then for f of 1, so here's our x value 1, and we're going down to the y value 4 right there, -4 rather. So f of 1 equals -4. For this problem, we're trying to figure out f of 5, 8, -1, and 2, which is essentially asking if I plug in these four different x values, what y values am I getting back, which I have to read off of the graph right here. So let's do the first one, f of 5. So if I look at the x value 5, so that's right over here on the x-axis, and I scroll up to the function itself, it looks like I'm getting a y value up there of 4. So we can say f of 5 equals 4. Now if I look at the x value 8 a little further down, so that's right here, if I look at where that is on the graph itself, that's -3 for the y value. F of -1, so that's the x value -1, and on the graph it looks like the y value there is 3. And then finally, f of 2, taking a look here, we're all the way up here with a y value of, let's see, looks like that's about 8. For this problem, trying to find f of -4 and f of 0, f of -4 is going to be the y value on the graph here, where the x value equals -4. So taking a look as I go along the x-axis back here to -4, where is that on the graph? That's right here at the y value -2. So f of 4 then, f of -4 equals -2. f of 0, that's the y value at x equals 0. So here's x equals 0, the origin. Going up here to where the graph actually is, that is the y value 5 up there. So f of 0 equals 5. For this problem, I'm basically looking up the y values at the x values -7, -3, and +3. So f of -7, the x value -7, which is right about here. What's the y value on the graph? Well, here's where we are on the graph at -7. That's a y value of -2. And then as we go a little bit further to the right to -3 for f of -3, the y value there is +2. So we have f of 3 equals +2. And then f of +3, that's going to be over here, looking at the graph. We have a y value down there of -4. On this one, in order to find f of 4, I basically need to replace all the x's in this f of x function with 4's. So I'm going to have 2 times 4 plus 4. And then we've got, this is going to be 8 plus 4, which is going to be 12. To find f of 3 for this f of x function, I have to replace all the x's in the original function with -3's. So instead of having 2 times x plus 4, I've got 2 times -3 plus 4. And notice I'm using a parentheses here so that I keep multiplying. Otherwise, it looks like I'm doing 2 minus 3, which is a little bit different. So 2 times -3, that's going to be -6. And -6 plus 4 gives me -2. For this one, I'm doing f of x plus 3 for this original f of x function. So just keep in mind that this x and this x here are not the same x. You could think of this as like an x1 and an x2. I'm going to pretty much replace the x in the original function, the x1 here, with x plus 3 instead. So instead of doing 2 times original x, I'm going to do 2 times x plus 3, new x plus 3, all of that plus 4, like so. I just erased and replaced x with the x plus 3 here. Now I have to simplify, so I'm going to have 2x plus 6 if I distribute. I still have the plus 4 over there as well. And then 6 plus 4 gives me 10, so 2x plus 10 will be my final answer. For this problem, I'm using f of x equals 2x minus 5, and I want to figure out f of 3 plus f of 1. So this is saying I have to plug 3 into the f function, and I also have to plug 1 into that same function, and then add whatever I get as a result of doing those two different things. F of 3, that's going to be 2 times 3 minus 5. I'm going to replace the x here with a 3, and I'm going to keep that in its own bracket just so I keep it separate from all this other stuff. F of 1 now, that's going to be plugging 1 in for x, so 2 times 1 minus 5, and I'm going to add that in its own bracket over here. And now that I've got all those x's swapped out for 3's and 1's, I'm just going to simplify this using a little PEMDAS. So over here I've got 2 times 3 is 6, and we'll keep all that together for now. Over here 2 times 1 is just 2, so no big changes over there. Now on the left side here, 6 minus 5 is 1. On the right side, 2 minus 5 is negative 3, so I'm doing plus negative 3 or minus 3. And 1 plus negative 3 is a grand total of negative 2. On this problem, I've got a little bit of work to do. I have to take the function f of x equals 2x minus 5, plug in 3x, plug in x plus 2 to the same function, and then subtract all of that. So let's take this one step at a time. Let's deal with f of 3x first here. Now keep in mind that the x's in this part of the problem and the x in the original function are not necessarily the same x. You could think of this as really being like an x up here, and you could think of this as like 3a, and this is like a b plus 2. That's really what's going on. The x is totally different. So f of 3x, I'm taking the x in the original function, and instead of doing 2 times x minus 5, I'm doing 2 times something minus 5. So 2 times 3x minus 5. And I'll do that in a bracket here just to keep it separate from everything else that's happening. Now I'm going to do a minus bracket with whatever f of x plus 2 looks like. So f of x plus 2, now instead of doing 2 times x minus 5, I'm doing 2 times parentheses x plus 2 minus 5. Now I have to simplify this a bit. So over here in this left bracket, 2 times 3x is 6x. Still have a minus 5 in there. On the right side here, we've got 2 being distributed. So that's 2x plus 4 minus 5, which you could say is 2x minus 1 eventually. We'll just clean that up a little bit for this next step here. And actually, let me go back a sec here. Looks like I'm going to be doing two things at once. So I've got the 6x minus 5. That doesn't need to change. I've got the 2x minus 5 is what's going to be in here. But now I'm going to also distribute this negative to this parentheses. So I'm going to have negative 2x. And instead of having the negative 1 that I was going to get from the 4 minus 5, I've got negative 1. So that's actually giving me a positive 1. So maybe a little confusing where that was all coming from. But I simplified in here first, and then I distributed a negative 1 to everything. Okay. At this point, I'm just going to combine like terms. 6x and a negative 2x combines to 4x, and negative 5 and positive 1 combines to negative 4. So 4x minus 4, final answer. For this problem, I've got this x plus 1 quantity squared f of x function going on, and I want to do f of negative 3 plus f of 4. So I'm going to kind of do these separately and then add them together. So f of negative 3, we're plugging negative 3 in for the x here. So I've got negative 3 plus 1 quantity squared. And to that, I'm going to add 4 plus 1 quantity squared. Okay, let's simplify things within these squared parentheses. PEMDAS says I have to take care of parentheses first. So negative 3 and 1 gives me negative 2, and that's being squared. 4 plus 1 is 5, also being squared, and we still have addition going on there. Now we do the exponents before we add together, still using PEMDAS. Negative 2 squared, this is negative 2 times negative 2, so that's a positive 4. And then 5 squared is 25. So 4 plus 25 gives me 29. This problem is a little bit of a beast. We have to take the f of x equals x plus 1 squared function and plug in 2x and also x plus 1, and then combine and simplify all that craziness. All right, so just keep in mind that the x's right here and these two x's down here are not the same x. They are totally different. You could think of them as like x1, x2, and x3 if that helps. With that little caveat, let's go ahead and do this. So f of x plus 2, that means wherever I see an x in the original function, I replace that with 2x from this one right here. So this is going to be 2x plus 1 quantity squared. Plus, now what does f of x plus 1 look like? Well, instead of writing x plus 1 squared from the original function, this x I'm going to replace with x plus 1. So we're going to have x plus 1 squared. So a little bit tricky there. Again, this x was being replaced by x plus 1 in blue here. Now I have to simplify a little bit. To make my life a little bit easier, I'm going to rewrite this stuff in here as x plus 2. And now let me go ahead and expand both of those squared binomials. So remember, when you have a squared parentheses with addition or subtraction, you have to square the first thing, multiply them and double it for the middle term, and then square the last thing. So squaring our first term of 2x, that's going to be 4x squared. 2x times 1 is 2x. Doubling that gives me 4x, positive 4x for the middle term. And 1 squared is just 1. Now we move on to x plus 2 squared, and we do the same process. So squaring the first term here, the x here gives me just x squared, and all of this is being added now. X times 2 is 2x. Doubling that gives me 4x. And then finally, 2 squared gives me positive 4. Combining like terms, we have a 4x squared and a 1x squared to give us 5x squared. 4x and 4x equals 8x. And then 1 and 4 is the constant 5. And that is as simplified as this is going to get. For the next couple problems, I've got the function f of x equals x plus 3, so not a whole lot going on with that function. We're just adding 3 to whatever you plug in. And here we're doing f of 2 plus f of 6. So I have to plug 2 into this thing, plug 6 into this thing, and then add those two results together. F of 2 is just going to be 2 plus 3. F of 6 is going to be 6 plus 3. And then we're adding those together. So we have really 5 plus 9, which comes out to 14. On this one, I'm doing f of x plus 2 quantity squared and using the x plus 3 function. Keep in mind that this x and this x are not the same. It's kind of like having an x1 and an x2 that just happen to have the same letter but don't really necessarily have the same value. So doing f of all this stuff really means replacing the x up here with x plus 2 quantity squared. So I'm going to have x plus 2 quantity squared plus 3 when I initially plug this in. Now I'm not simplified yet. I actually have to expand this x plus 2 squared a little bit. So squaring the first thing gives me x squared. Multiplying these and doubling it gives me 2 times 2x, so 4x for that middle term. And then 2 squared is going to be 4. And then don't forget you actually have this plus 3 that was there originally. To simplify now, I just do 4 plus 3, which is 7. So x squared plus 4x plus 7, final answer.